Okay, here are today's notes for Joe the Skydiver. You should already have your skydiving note sheet open and ready. You can find that in Schoology under the vector folder, and then you can share it across into Notability, or if you want to just write it on paper, that is fine as well. The very first part of this worksheet here, you can see at the top, it says go, Joe Physics goes skydiving. There's all this interesting notation there that says the Air Force, F with the word air as he skydives with the parachute closed, and then F air when the parachute opens. Basically what this is talking about, because we are going to analyze the force and the acceleration of a person skydiving, is it's just something that we actually made up, we meaning the physics teachers, made up this equation to just represent what happens to the speed and, based on the amount of force coming from air resistance if you are falling with your parachute closed, which would be this, this one here, or if you were falling with the parachute open. So what you would notice is that if the parachute is open, which is the second one here, you would be taking 150, which is just an arbitrary number that we made up, times the velocity. And if the parachute were closed, you're only taking 10 times the velocity. So think about that. You're going to have a much smaller force from air coming on you if your parachute is closed. Once you open your parachute, you're trapping a ton of air. So if you're trapping a ton of air, you need a bigger number. You're going to have a much bigger force. So that's what those two things are. One is for when the parachute is closed. One is for when the parachute is open. Okay, so what I want to do is take this thing and just kind of put it off into the corner and, just jot that down in your notes on the side, that F air is the force from the air resistance, and it's either, there are two cases, it's either when the chute is closed or open. Those are the two cases. And when the chute is closed, the force due to air, you're going to find by taking 10 times the velocity. And when the chute is open, it's going to be trapping a lot more air because the chute is open, right? Picture that. Somebody skydiving, if you open the parachute, it's trapping a ton of air. That's why you slow down. So open and closed. Those are the two numbers there. Okay, so let's go ahead and start. And I want you to follow along and write this down in the notes. The first one says, what is Joe's weight? Well, this one you should be able to do. Force due to gravity is mass times gravity. That's the equation we want to use. So for number one, to find his weight, we know that the mass, if you look at your sheet there, is 100 kilograms. Oops. Freaking you out by moving all of this. Didn't mean to do that. 100 kilograms. And we're trying to find the force, right? So force due to gravity is mass times gravity. And if you see at the top, the worksheet says go ahead and just use 10 for gravity. It just makes it easier. So for number one, the weight is going to be 100 kilograms times 10 meters per second squared. So we get 1,000, and what's the unit? Newtons, because it's a weight. Number two asks to find the downward acceleration just as he steps out to go skydiving. So the parachute is closed, and we already know that, there's no air resistance on him yet or anything. He's just stepping out. He hasn't started to fall or anything yet. It's like just at that very first instant that he leaves. So if we take a look and just kind of draw all the forces that are acting on Joe Skydiver, and he looks a little afraid because he just stepped out of a hot air balloon, and he's going to fall. Here's the hot air balloon basket with the strings going up. So there's the balloon. And he's out now and jumping and falling. So the forces that are acting right now is you've got his weight, right? Force due to gravity. And there's no air resistance headed in the upward direction yet because he hasn't started to fall. So since there's no air resistance yet, that means his weight is the net force. So in that case, if I want to find acceleration, I know that F net is equal to m times a, and I'm solving for a, so I do F net over m, which gives me 1,000 over 100, and I am right back where I started. Right? We know that the only reason that Joe the skydiver is accelerating is due to gravity, and since we don't have any air resistance yet, the acceleration right when he steps out of the balloon is going to be gravity. So it's a little bit of a trick question, but the reason that you end up right back with 10 is because we don't have any air resistance just quite yet. So for number 3, the question asks, after he's fallen for a few seconds, now we do have air resistance. So you can see that it says the air resistance now is 270 newtons. So we're going to use that new equation that I said that, we just sort of made up. The parachute is not open yet, so we're going to use the equation that says F air. Let's get that written here. Oops. Is 10 times the velocity. We want to know how fast, so we're solving for velocity. And the problem here says that the force due to air is 270 newtons. So we're going to solve by going like this. 270 equals 10 times V. So we're going to divide by 10 on both sides. Cancel, cancel. 270 divided by 10, we get 27. So the velocity is 27 meters per second. That's how fast Joe Skydiver is going so far. Part B says, draw the force vectors acting on Joe. What is the size and the direction of the net force? So let's go ahead and draw Joe here. Here's Joe. And now he has jumped out and he's falling. And so he still has weight. He didn't become weightless. And now he also has air resistance working on him. And so that's what the force vectors would look like. Force due to gravity going down, force of air going up. So we want to know what's the net force. Well, what is my force due to gravity going down? It's 1,000 newtons because that's his weight. And the force due to air going up, like we just read from the problem, is 270 newtons. So if I want to know my net force, I'm going to take 1,000 and I'm going to subtract 270. And now I know that my net force is 730 newtons. So that would be part B, or part C. So part B was to draw the vectors, part C was to just find the net force. And then D says, well, now what's the acceleration? Because, now there's air pushing up on him. So your acceleration is going to change because there's air pushing up even though your weight is pulling you down. So for part D, if we wanted to find the acceleration, we're going to take the net force over the mass. So we're going to take 730 divided by 100, and we get 7.3 meters per second squared is how much we are accelerating. And this is down, right? Because the force in the downward direction is 1,000 newtons, and the force in the upward direction is 270 newtons. So clearly, which way is winning if we're going to talk about, like a tug-of-war situation? Down has the bigger force. So we're headed down still with 730 newtons of force with an acceleration of 7.3 meters per second squared. Part 4 says, now what happens if Joe, skydiver here, reaches terminal velocity? So there's a little bit of a vocab word here. Terminal velocity means your end speed. It's as fast as you're going to go. And terminal velocity will happen when Joe skydiver's weight, his force due to gravity, is exactly equal to the force due to air. So when his force due to gravity is exactly equal to the force of air and we're balanced, you're going to be moving at a constant velocity. And that constant velocity is as fast as Joe skydiver will be able to go as he's falling through the air, because it's exactly when those two things are balanced out. It doesn't mean that he stops moving. It just means that he's moving at a constant speed, like cruise control. So part A says, what is his acceleration? Well, if you're moving at a constant velocity, what is your acceleration? It's 0, of course. Right? Our speed is constant. How about B? Part B says, what is the net force? Do you know? Well, isn't net force equal to mass times acceleration? And didn't I just say that acceleration is 0? So net force also has to be 0. We want to draw the force vectors on Joe. I already did that. I have force due to gravity pointing down and force due to air pointing up. And now I want to figure out how fast he's going. So let's go ahead and still use that same equation, because we haven't opened the parachute yet. So force due to air, this is for part D. Is equal to 10 times the velocity. And we know that your force due to gravity and your force due to air are equal. So I know that my force due to air has to be 1,000 newtons because it equals his weight. So I'm going to go ahead and say 1,000 equals 10 times V and solve for V. Divide by 10, divide by 10, cancel, cancel. My velocity is, holy cow, 100 meters per second. That is super fast, and probably, well, most definitely unrealistic for somebody falling. It wouldn't be quite that fast. It'd be probably about half as much as that. But just for fun, we have our stick figure Joe physics going about 100 meters per second. Okay, so then the next part says, finally, the parachute pops open. Okay, so now we've got Joe Skydiver. Part B wants us to draw the force vectors. So let's go ahead and do that right off the bat and draw the force vectors on Joe Skydiver. And so now he's got a force due to gravity coming down, and he's got force due to air going up, but now he's got his parachute finally open. Now it wants to know if he is moving that fast. So if I've got a velocity of 100 meters per second, holy cow, how much air resistance must be acting on him and the parachute. So you have to look all the way back up to the top of your worksheet and remember that we are now looking at this new equation. So when the parachute is open, our force due to air is now 150 times the velocity. So let's go ahead and do 150 times the velocity of 100 and find out that our force due to air is 150 times 100. It's a very big number, 15,000 newtons. So we have 15,000 newtons going up, and we still have our 1,000 newtons of weight going down. So when that parachute pops open, you know, that is a huge force in the upward direction. So to answer part A is 15,000 newtons. Part B is the drawing that I have on the right there with the force due to weight going down, the force air going up. And now I want to know, what is the acceleration? Well, to find that, what do we need? We need the net force. So F net is going to be 1,000 minus 15,000. So I get a negative 14,000 newtons is my net force. And then I can go ahead and find my acceleration by taking net force over mass. So when I do that, I get a negative 14,000 over 100 kilograms, which he still is. And I get an acceleration of a very big number. Take 100 and take 2 off of that is 140 meters per second squared. And now the negative just means up, because for this entire problem, all of the positive numbers were in the downward direction. So definitely if we're looking at a tug of war between the force vector due to weight and the force vector due to air, the air resistance is winning in this case. So it's going to be accelerating in the upward direction, or the other way you can think about this, because clearly if you're parachuting, you're still falling down. It's like you're hitting the brakes. It's just like if you drive your car and you're going 30 miles an hour and you hit the brakes, you're still moving forward. You're just slowing down. So Joe the skydiver is still falling down. He's just not falling down as quickly. It's like you're hitting the brakes when you open the parachute. And lastly, we're almost done taking notes here. It says, how fast will he be going once he reaches the new terminal velocity? So again, you want to be using this new equation with the parachute open. F air is 150 times V, so that's the equation you want to use. And the key word here that you want to think about is terminal velocity, and what did we learn about that before? That if you have a terminal velocity, you've got your force due to gravity is equivalent to the force due to air. So in that case, we know that our force due to gravity, is force due to air, is going to be 1,000. It's just his weight. So we'll go ahead and plug that into this equation over here. So we've got 1,000 newtons is equal to 150 times v. So I'll divide by 150 on both sides. Cancel, cancel. And I end up with a velocity of 6.6. meters per second. So still sort of fast, but not so fast that you can't land with your parachute. So we are finished taking notes with this worksheet for right now, and you're going to go ahead and move forward with some practice problems using these notes as reference.